Hello everyone, my name is Abhishek and welcome back to my channel. Today is episode 2 of AI Assisted DevOps Zero to Hero series, and in this episode we will focus on prompt engineering. So prompt engineering is a very important skill when it comes to Gen AI, and it's also super simple. That's why in today's video we will start with learning the fundamentals of prompt engineering. Then we will learn various prompt engineering techniques or types, such as zero shot prompting, few shot prompting, multi shot prompting, and chain of thoughts. Out of which, few shot prompting is very popular. It is highly recommended as well. That's why in today's video, I will also do a demonstration of few shot prompting where I will show you how in real time DevOps engineers can make use of few shot prompting to get desired output according to their organizational requirements. Overall, it's going to be a very interesting session. So make sure you watch it till the end. Let's get started. First things first, what is prompt engineering? In a layman terminology, let's say there is a AI model, maybe a large language model. So usually user provides input to the large language model, and depending upon the input, it generates the output for you. Now, the input that is provided by the user is called as prompt. And the way to enhance the user's input to let AI model generate the desired output or the expected output is called as prompt engineering. So prompt engineering is a way of enhancing the user's prompt or writing better prompts to let AI models generate output that is expected. Let me show you with an example. Let's go to ChatGPT and assume my requirement is to get a Kubernetes deployment manifest, deployment YAML file. So I'll just say generate a Kubernetes manifest for deployment resource. I mean, on the first sight, it looks very good. Like the input looks to be accurate. Let's try to give this input or the prompt and let's see if ChatGPT responds with expected output. It's good that it provided the deployment YAML file. However, if you notice, it provided this description, which is not something that I'm interested. It provided the explanation, again, something that I'm not interested. Steps to apply the manifest, check the deployment status, and a suggestion as well, which I am not at all interested in. So how do I make this output better or something according to my requirement? So I should enhance the prompt. So I should basically write a better prompt, which I will do by modifying the A character here and replacing it with only. So generate only Kubernetes manifest for deployment resource. Let's see if it works. Perfect. So I got the expected YAML manifest. So what is the simple technique that I used here? I just made my prompt more specific by replacing the A keyword, A character, and placing only word. So this is called as direct prompt or zero shot prompting, where I try to be more specific. So this is a basic example of prompt engineering where you can get output exactly what you need. Now, before we head towards learning other types of prompt engineering or other techniques, you might ask me, Abhishek, is this the only advantage of prompt engineering? No, there is another significant advantage of prompt engineering, that is costing. A good prompt can significantly reduce the cost for the organizations. Let me explain how. So we will take a real-time use case where a DevOps engineer is assigned with a task to automate this. That is, any developer, if provides an input similar to this, or let me explain it here. So let's say, as a DevOps engineer, you are expected to write a Python script where the Python script reads single input from the user. If the user inputs Kubernetes kind as deployment, then the Python program should generate, listen to the problem statement carefully. I said it should generate a Kubernetes deployment manifest. If user's input is service, then the Python script should generate Kubernetes service YAML file or the manifest file. Similarly, the Python program should support all the native Kubernetes resources, secret, config map, service account, everything. Now, how do you write this? If you listen to the problem statement, I use the word generate. That means basically you should be looking at large language models because they are good at generating the output. Now, okay, you might use large language model, but how do you actually prepare this Python script? How do you automate this process? You can do it in 2 steps, right? Step 1, you can prepare the prompt, just like how we prepared in the previous example for the deployment manifest. You can either prepare this prompt or you can prepare this prompt. Then once the prompt is prepared, you will make an API call to the large language model because that can generate things for you. Now, you cannot make API call to ChatGPT because it's just a chatbot. It is just for your learning purpose. What you need to do is you should be using large language models hosted by maybe OpenAI or DeepSeek or other equivalent things. You might ask, Abhishek, how about local large language models? I'll come to that point. For now, let's focus on this. So step 1 is to prepare the prompt. Step 2 is to make API call to the large language models, either hosted by OpenAI or DeepSeek or equivalent. Now the big problem here is that the API calls are not free. Why? Because either OpenAI or DeepSeek or any equivalent company, what they need to do is they need to set up the infrastructure, they need to set up the hardware, they need to buy the GPUs. On top of that, they will run these large language models. So when you make the API call to the OpenAI endpoint, we will learn all of it, how to do it, how to write the Python script in lecture number 3. For now, just understand the theory part. So when you make API call, then the request goes to OpenAI infrastructure, which is running somewhere, and the GPUs process your request, LLMs process your request, and they send the output back. But for this entire thing, OpenAI will charge you. Now, this is where a good prompt and a bad prompt can make a difference. If you are writing a better prompt, the one that you see here is better prompt because it generates less text. It generates the text exactly what you need. Whereas this is a bad prompt because it generates more text. Abhishek, what happens with text? So what if I'm writing a bad prompt and it generates more text. So the concept of API requests, the costing of API requests is based on something called as tokens. More the number of tokens, more is the cost of your API request. And tokens are directly or indirectly related to the words. For example, if you take Gemini model as example, for every 100 words, it is roughly 60 to 80 tokens. That means in this case, there are more number of tokens because there are more number of words. Whereas in the second prompt that we provided, there are less number of words. That means less number of tokens. So less is the cost. Abhishek, would that matter that much for a single API request? Obviously, for single API request, it doesn't matter that much. But when you are doing it scale, when you are sharing it with your organization, every day 100 developers might request it. Overall, throughout a year, there can be thousands of requests or there can be millions of requests to this Python script. So that will make difference between the bad prompt and good prompt. Abhishek, I want to understand more about tokens. Let's try that. So basically, you can go to Google AI Studio. So just go to Google AI Studio. You can create a free account. And let's try the same thing to understand how many number of tokens the bad prompt generated and how many number of tokens the good prompt generated. Okay, generate a Kubernetes manifest for deployment resource. Let's run it. So you can see here the tokens number. Once the prompt is complete, okay, it's still generating. And the tokens, you can see the refresh token count here. It is 2473 for the bad prompt because there is a lot of useless information that is generated. Now let's look at the good request where I will copy this and we can refresh. Just remember it is roughly 2500. Now the token count is 0. Let's put it here and try to see what is the token count. So it is just 179. Previously it was 2500 and now it came down to 179 or roughly 150. So you can see the difference in the number of tokens, right? For 1 million token, there will be a pricing, or let's say for 1000 token, there is a pricing. Reason why I'm not talking about the pricing is because different AI models have different pricing at this point of time. So just remember that as the tokens go up, the price for the API request also go up. Tomorrow's video, when we talk more specific about the API requests, when we look at OpenAI, DeepSeek API requests, then you will come to know how much tokens are costed. So this is how prompt engineering can affect the costing as well. Overall, we learned prompt engineering can help you with generating the desired output, and it can also help you with respect to cost optimization. Perfect. I hope this is clear. So now let's move ahead to understanding zero-shot prompting, few-shot prompting, multi-shot prompting, and chain of thoughts. Basically, they are very, very simple to understand. It's something that you should develop as a practice, but they are very easy to understand. When it comes to zero-shot prompting, this means you provide a prompt without any example. Till now, whatever we did as part of this video is zero-shot prompting. We asked ChatGPT or Google AI Studio to generate a Kubernetes deployment manifest, but we did not provide any example to it because Kubernetes deployment manifest is something I'm sure the AI model should be trained with, and I'm sure it can generate the output. That's why I did not provide any example. So direct prompting, zero-shot prompting is also called as direct prompting. This is useful when you are going with popular or familiar use cases, and it works absolutely fine. You don't have to provide an example. Whereas few shot prompting is something where you first provide some examples, right? And then you provide the prompt. First, let's take a generic example. Then let me explain from DevOps point of view. So again, if you go back to ChatGPT, if you ask, create a random name which starts with A. So what ChatGPT does is, it just provides a name, right? Now, what if I want ChatGPT to provide the name or to provide the output in a particular format? So what I'm going to do is I'm going to provide some examples. So I will say first, example, create a name that starts with B. ChatGPT, your answer should be random name for alphabet B is Batman. Then I'll provide another example. Basically, we are training it with our use case. Create a random name which starts with S. Random name for alphabet S is Superman. Now, when I ask the same thing, create a random name which starts with A, you will see that the output is not generated in this format, but it will be generated in the format that we are looking for. Perfect. So it said random name for alphabet A is Aquaman. So for B, I said Batman, S for Superman, and for A, it said Aquaman. I did not provide any description to it. I just used the same prompt, but what I did is I provided examples. Because we provide few examples, this type of prompting is called as few shot prompting. Abhishek, please explain me from DevOps point of view. I understand that is very important. So let's try to learn from DevOps point of view. It's a very, very important use case because a lot of times you can go to ChatGPT and you can ask ChatGPT to generate a shell script. And what ChatGPT does is it generates the shell script, which is very ideal, but it might not be something that is according to the standards of your organization. Please understand this. Every organization has a coding style. Maybe in your organization, you have a coding style where whenever someone writes the shell script in your organization, they provide the author name, they provide the version, they provide the date, and only then they write the script. And maybe in your organization, you avoid certain kind of keywords. Or maybe you always declare variables in a particular format. Now, ChatGPT definitely is not aware of it, or large language models are definitely not aware of it. So, how do you tell ChatGPT or large language models to generate the script according to the format or style of your organization? This is where few shot prompting comes handy. So what we will do is, let's say you want to ask LLM to generate a shell script for you. So before generating the shell script, you provide some examples to it, where I will say, example, let's say the shell script is to print the, or let's say fetch the Docker version and answer where I am trying to, this is a question for the example, and this is the sample answer, where we are just trying to train the large language model with our requirement. Not exactly training, but we are trying to explain the format that we need. So here I'll say shebang slash bin bash. Then I will say author Abhishek.Veeramalla, version v1. Then I'll say date, close the comments, and only then the actual script starts. Let's say this is the format of your organization, where for Docker version, let's say you have Docker hyphen hyphen version. Similarly, let's provide another example for Terraform. Fetch the Terraform version. And here I'll mention Terraform hyphen hyphen version. Now I will ask ChatGPT to fetch the versions of all the services that are installed on a virtual machine, or all the processes, let's say. Let's see if it can generate according to your organization style. See, first it started with shebang, author, version, date, and then it generated the complicated scripting for us. What's important? You need to note that you provided it with a particular format or a style or the desired output that you want, and it generated exactly the same. This style of prompting is called as few shot prompting, and it is the most recommended prompting style. Even I would recommend it because a lot of times large language models do not have the context, right? They know the ideal answer, but they don't know the context. They don't know what exactly is your requirement. They don't know anything about your company. You might be running large language model locally, you might be running it externally. It always gives you the ideal output. To make it give the output that you need, always provide some examples. Okay, that is, always try to provide the context. You will learn more examples of few shot prompting as we proceed with this series. Throughout the series, for the next 7-8 episodes, we will definitely use prompt engineering. And every time I use prompt engineering, I will try to share some insights. Now, multi-shot prompting is, let's say you're working on even complicated use case. Then not two examples, but you can provide more examples. So multi-shot prompting is just similar to few shot prompting, but you provide more number of examples, right? You provide more context to it, more examples, things like that. Finally, chain of thoughts. Chain of thoughts is a prompting style that actually enhances the performance of large language model. So basically your large language model can perform better if you use chain of thoughts prompting style, because it basically encourages the large language models to use its reasoning capabilities. So if your LLM has reasoning capabilities, using chain of thoughts, you can actually derive best output from the models. However, at this point of time, it becomes too much for the beginners. So we will learn more about chain of thoughts as we proceed with the next videos of this series, and as we talk about AI agents. For now, I hope you understood zero shot prompting, few shot prompting, multi shot prompting, and why and how prompt engineering is useful. One final thing I would like to say before concluding this video: better than writing these kind of prompts, right? All the prompts that I have written here are for the purpose of video. Always try to write more elaborated input and make sure the output that is provided by the large language model is concise, right? Always you should make sure that input is as clear as possible, but the output provided by the large language models is only what you require. So for that, always try to follow a strategy, starting with provide context. Like you can explain that, I'm a DevOps engineer or I'm currently working on a particular project, so that your LLM gets context of what you are doing. Then you should be providing the instruction. You should provide examples. That is, you should be using few shot prompting as much as possible. At least that is something that I would recommend, so that you get the better performance from the model. And you should be also defining the output format. Let's say you want the output in the MD format, or you want output in the JSON format. So you can just tell, no, whenever you provide this input, you can just say here, please provide the output in MD file format, and you will get the output in the MD file format. So it is currently analyzing, and it should generate the output for us in the MD file format. See, it generated the MD file which you can download. So always try to provide the MD file format, the formatting style of the output. So this is something that I would recommend instead of just writing a prompt. Provide the context, provide the instruction, provide the examples, and output format that you need. I hope you got a clear understanding from this video. Let me know in the comment section if you have any questions. I will see you all in the next video. Take care, everyone. Bye bye.